Hello, this is Miss Popelka, and I'm going to work the Algebra Study Guide Retake practice exam for you. And I need to add before I get started that I'll be going fairly quickly. This is meant to simply be a review. If you get to a couple questions when you come to class tomorrow, please make sure that you let me know if you need something a little bit more in depth. We'll see what we can do. Also, if you look also on our Edmodo site, you're going to see some other links to probably some of the exact same problems that are, well, actually not probably, I know for sure, for some of these exact same problems that are on this study guide. So that might help you as well. So first of all, for number 1, it is saying 92 is added to 5 times a number, and the result is 200. So we need to write an equation to model the situation and then solve it. Of course, because it's got an equation, it's going to have an equal sign. When it says the result is 200, it means that this 92 is added to 5 times a number is all going to be equal to 200. So the equation that we're going to write, we need to look at the rest of our words. So it says that 92 is added, so that means we're going to do 92 plus something, and then 5 times a number. So we don't know what that number is, so that's why we're going to do 5x. So we're going to use the equation 92 plus 5x equals 200. So that's the equation, and now we need to solve it. So I'm going to, I should also note that you could have said 5x plus 92, or even flipped it and said something like 200 is equal to 92 plus 5x. That's fine as well. It doesn't really matter. You don't have to do it in the same order that I do. As long as it's 5 times a number added to 92, and then it's all set equal to 200. So I'm going to begin solving by subtracting 92 from both sides. In order to isolate the x, which is my whole end game, that's going to leave me with 5x on this side of my equation, because that's gone. And it's going to leave me with 108 on the right side. Of course, we all know by now, in order to further isolate that x and get rid of the 5, I have to divide both sides of my equation by 5. So that is going to leave me, I'm going to write it over here with a green, this will be isolated, which will leave me just with an x is equal to 21.6. It's okay that it's a decimal. Some of you guys got confused about that before. In algebra, we have decimal numbers all the time. So just remember 21.6 is perfectly acceptable. Doesn't matter that it was not a whole number. For number 2, it said Raymond is solving the equation right here. And this was the first step of his solution. It asked you to describe what steps he likely took to arrive at x minus 14 is equal to 421. Well, hopefully we know by now that whenever we see something like this, that is our cue that we need to do distributive property. So more than likely, that's what Raymond did. He did 3 and distributed it to those numbers inside of the parentheses. So he likely did 3x minus 12. And then, of course, the rest of the equation hasn't gone anywhere. We still need to account for that. Then he more than likely combined the terms that he had in common, the like terms. So he had 3x and negative 2x. Then he had negative 12 and negative 2, which is why when he puts 3x and negative 2x together, he likely ended up with this x up here. When he did negative 12 minus 2, he ended up with x minus 14. And there we have it, the equation that he ended up with. So if we needed to put it in writing, exactly what did Raymond likely do? Well, first of all, he distributed 3 to the x minus 4, and then finally he combined the like terms. In other words, he combined the 3x and the 2x, and the negative 12 and the 2. For number 3, it is asking us to solve this equation. I know this one is a toughie, but you guys can do it. And what I personally would do, I'm going to rewrite this over here. There are multiple ways that you could solve this equation. Right now we've got an x on both sides, so you could technically add an x to both sides and do all that. But because of this x divided by 4, the first thing I would do is get rid of this 4. And because it's x divided by 4, what is going to cancel out a divided by 4? Well, we know it's going to be a multiply by 4. Now, if we're going to multiply this x divided by 4 in order to get the x by itself, remember the way equations work, we've got to multiply this whole equation by negative 4. So I'll show you or by 4, not negative 4. So first of all, if I do 4 times negative x over 4, that's going to cancel that one. And then if I do 4, so I've got a negative x left over right here. Then if I do 4 times 7, that's going to give me plus 28. Then if I do 4 times 2, that is going to give me 8. Then if I do 4 times that negative 8, that will leave me negative 4x. So I did manage to get rid of that division to make it a little bit easier now. Now we just have an equation with variables on both sides, one that we're a little bit more familiar with. So I am going to get rid of one of those x's. Really doesn't matter which one I get rid of. But I'm going to go ahead and get rid of, you guys know how much I hate negatives, so I'm going to get rid of this negative 4x. To get rid of a negative 4x, I'm going to add 4x to both sides of my equation. That'll leave me with 3x plus 28 is equal to 8. Sorry for that interruption, folks. I was big time running out of room, so I decided to kind of pause for a second and redo it. I'm going to rewrite the equation over here again. And again, I'm just going to, it's probably worth saying one more time anyway, that I decided, even though there are multiple ways to do this, the easiest thing was to get rid of this little x divided by 4 over here, so that I had something a little bit more easy to work with. So of course, in order to get rid of a divided by 4, I have to multiply by 4. And the way that equations work, if I'm going to multiply this negative x over 4 by 4, I have to multiply everything by 4. So I'm going to do 4 times this negative x over 4. Of course, that's going to cancel, just like a regular one-step equation. And it's still going to leave me with this negative x that I had up here. Then I'm going to do 4 times 7, so that'll be plus 28. Stick my equal sign in there. 4 times 2 will give me 8. And then 4 times negative x will give me negative 4x. Just like I did a second ago, I'm going to add 4x to both sides. That is going to leave me with 3x plus 28 is equal to 8. If I subtract 28 from both sides, that'll leave me with 3x is equal to negative 20. And then finally, for my last step, I have to divide both sides by 3. If I do that, x is going to be equal to a negative, and it's actually a 6.6 repeating, so I'm rounding it to a negative 6.7, which will happen to be D for our answer as far as our answer choices. Number 4 asks us what is the equation of this graph, and we're going to put it in slope-intercept form. So we know it's y equals, first of all. The second thing that I'm going to try to figure out is what is my rate of change, because I'm going to need that for my equation as well. So I am going to choose 2 points on the graph where it kind of hits in the corner. I'm going to look down and over, and I'm going to notice that it goes down 1 and it goes over 2 for my rate of change. It's slanting downwards, so it's going to be a negative. So that means my slope is a negative 1/2. I need to put the x in front of it. And then finally, of course, the second half of our slope-intercept form is the y-intercept. So right here where the graph crosses the y-intercept, and that is a negative 2. Let me erase this stuff out of the way just to make sure we can see. The graph crosses right here at negative 2. So the equation of our graph is y equals negative 1/2 x minus 2. For number 5, I just realized a typo when I was going through here, sorry. Provide a point that falls, not fall, on the line. on the line. I noticed I repeated that twice too. Whoopsie, sorry guys. Represented by the equation y equals 2x plus 7. So in other words, which one of these points will work in this equation? So really, it's just some trial and error. So I'm going to take my equation over here. First, I'm going to put my first point in. So I'm going to put a 1 in for x, and I'm going to put a 12 in for y. Let's see if that works. So instead of 2 times x, I'm going to do 2 times 1, which is 2. 2 plus 7, nope, it isn't 12, so that means that A is out. So let's plug in, let's plug in the second option. So the second one, 0 and 10. So if I plug a 0 in for x, if this one is the right one, I should get 10 out for y. So 2 times 0 is 0. 0 plus 7, isn't 10. So that one's not going to work either. So let's try our third point that we're provided, the negative 5, 3. So 2 times negative 5. I'm going to put negative 5 in for x, since negative 5 is my first coordinate. So 2 times negative 5 is negative 10. Negative 10 plus 7, there we go. Negative 10 plus 7 is negative 3, which is exactly what y should be for C to be the correct answer. So that means that C is the right point that works for number 5. Now for number 6, which is asking us to graph the linear function y equals negative 1/2 x minus 4. Now this is in slope-intercept form. So of course, as we know, this is the slope, that is the y-intercept. So I'm going to go down 1, 2, 3, 4 on the y-intercept to represent that negative 4 y-intercept. And I've got a slope of negative 1/2, which as we know means down 1 and over 2. We're going down because it's negative. So from this point, I'm going to count down 1, and then I'm going to move over to the right 2 places. Now I've run out of graph, so instead I'm going to kind of do the opposite and go up. And from here I'm going to go up and then over. So that now I have myself a graph of negative 1/2 x minus 4. Number 7 is asking us to find a solution for this equation. Of course, this and this indicate that we're going to have to start off with good old distributive property before we do anything else. So I'm going to distribute my 3 to my x and my negative 12. So that'll give me negative 3x plus 36. Sorry. Oh, I don't know why I just wrote 32. Set it equal to the 2 distributed over on this side, negative 2x plus 14. Now I've got a nice little equation. It just has a variable on each side, so it's a little bit easier to work with. Doesn't matter which one of these x's I get rid of. For no particular reason, I'm just going to get rid of the negative 3x. So I'm going to do plus 3x on both sides. That's going to leave me with a 36 over here and an x plus 14 over here. Now look, guys, I've just got myself a plain old one-step equation because I don't have a coefficient over here with the x anymore. So of course I just need to subtract 14 from both sides. That is going to leave me with 22 over on my left-hand side is equal to x on the right-hand side. For number 8, it says Michaela's beaker is partially full, and it gives you this expression to represent the total height of the beaker. You can see from the diagram, this is the height of the whole thing, and then this is the height of just part of it. So we've got to figure out the missing piece. This is one of those problems that I told you is really, really silly, but we've got to, somebody that writes these tests decides it's important. So all we need to do is subtract these polynomials. So 5x squared plus x plus 2, and then I'm going to subtract this one, so negative 3x. Now, because it's a minus 4, and we're really going to be subtracting that minus 4, that's really going to turn this into a plus 4. So now I'm just going to combine my like terms. The 5x squared doesn't have another x squared to combine with, so I'm just going to leave it be. X and negative 3x combine to make negative 2x, and then 2 and 4 combine to make 6. So the answer is 5x squared minus 2x plus 6.